Hi, today we're going to talk about solving three systems, a 3x3 system using Gaussian elimination. Now, we have a system right here with, we've got three equations with three variables. First thing we need to do is set up our matrix. So when we set up our matrix, it's going to be just like we did in class. Going to be looking at the coefficients 1, 1, 1, 2, negative 2, 0 because there's no x variable, and then negative 1, 1, 3. And then you're going to have your equal sign, 4, negative 2, 4. Okay, so this is going to look a little bit different than you've probably ever seen before, but you need to know how to do it and how to recognize it. So first things first, you're going to think about how you're going to be able to eliminate some things. So you're going to have to be able to use the process of elimination. So for this first one, this is how I'm going to note this. So you're going to multiply row 1, multiply row 1 by negative 2, then you're going to add it to row 2. So essentially you're doing this all in one step, whereas normally you would just do it, just one time. So negative 2 times row 1, so you've got negative 2 times row 1, so 1 times negative 2 is negative 2, add it to that, which is 0. And then you're not doing anything to row 1, you're just going to fill it in just like it is right up here. And then you're going to multiply this row 1 by negative 2. Negative 2 plus negative 2 is a negative 4. And then negative 2 times negative 1, or just times 1, is negative 2. And then you add it to that, which is negative 2. And you're going to do the same thing with your answer over here. You're going to multiply this by negative 2. So 4 times negative 2 is negative 8. And then you're going to add it to negative 2, which is negative 10. And then you didn't do anything with row 3, so it's going to stay here just like it is. Okay. So for this next step, you're going to add row 1 to row 3, because you can see that you can eliminate this first x. So your ultimate goal in all of this is to be able to get 1's diagonal, and in this space right here, like in all this space, you want 0s. So we've got a 0 right here from this step. And when we use this one right here, it's going to also eliminate this one. So go ahead and draw your matrix. So you're just going to add row 1 to row 3. So 1 plus negative 1 is 0. 1 plus 1 is 2. 1 plus 3 is 4. And then 4 plus 4 is 8. And then you didn't do anything to the first row. So 1, 1, 1, and 4. And then 0, negative 4, negative 2, negative 10. Okay. Now, when you're doing Gaussian elimination, you don't necessarily use division, but what you say is you do multiplication by fractions, which is basically the same thing. So what you're going to do in this, you're going to do like a combo step. You're going to multiply row 2 by 1/2, and you're also going to multiply row 3 by 1/2. So you're going to have this new matrix. And it's cool with matrices, you can multiply, you can switch rows, and it doesn't really change anything because it still stays balanced. So from here you're going to say 0, and then that divided by 2 is -2, -1, and -5. And then multiply by 1/2 on this row 3 is 0, 1, 4, 2, and then this one right here is 4. Sorry. On this next step, what you're going to do is you're just going to switch row 2 and row 3. Okay, so to be able to get that diagonal with, you're going to go ahead and put in your row 1 because it's still going to stay the same. So then you're just going to switch. So it's going to be 0, 1, 2, 4, and then it's going to be 0, -2, -1, -5. Okay, so on this next step, what you're going to do is you're going to multiply row 2 by 2. So you're going to say multiply it by 2, and then you're going to add it to row 3. So you're going to leave that first row alone. And then you're actually going to leave this second row alone, but it'll help you be able to fill out this one right here. So you're going to multiply it by 2 and add it to row 3. So 0 times 2 is 0, plus row 3 is 0. So 2 times row 2 is 2, plus 2, -2 is 0. And then 2 times 2 is 4, plus -1 is 3. And then 2 times 4 is 8, minus 5 is 3. Okay, on this next one, because remember your ultimate goal is to have zeros all right here and then ones down the diagonal. Okay, so our next step is going to be to multiply row 3 by 1/3. So this matrix C is going to be still, that row 1 is going to be the same. 1, 1, 1, 4. And then row 2 is also going to stay the same. 0, 1, 2, 4. And then you're going to multiply. So 0, 0. 3 times 1/3 is just 1. And then 3 times 1/3 is also 1. So once we get to this point right here, this is what we want right here, because this is x, this is y, and this is z. So from here, you know that there is one z. There is one z, and that z is equal to 1. So now you have, your one of your variables, one of your values. So then what you can do is you can take one of the this equation right here, which is y plus 2z equals 4, and then plug in your z value that you know, that you just found out what it is. So y plus 2 times 1 equals 4, y plus 2 equals 4, and then y equals 2. So there we have our second variable, our second value for that variable. So now we can just plug it into this first equation. So it will be x plus y, which is 2, and then plus z, which is 1, equals 4. Okay, so I'll plug this in. See that? Right there. Okay, so I've plugged it in, and now all I have to do is x plus 3 equals 4. Now I just solve, so x equals 1. Okay, and now we have gotten all of our variables, all of our values for our variables, and how our system works. It is now a working system. Okay, I hope this helps. Thanks.